A quotation from Durham University professor Carlos Frank: "I've dedicated my entire life to the development of a specific hypothesis about the cosmos, and while that idea is being questioned, I applaud it since it signifies the advancement of science." James Webb is disproving almost everything that has been accepted as true in cosmology for a century. A newly discovered ultra-deep image reveals, once more, the errors in our understanding of astronomy. The telescope that was meant to reveal the universe's first stars is beginning to destroy the pre-existing paradigm and may lead to the discovery of entirely new science. Not all researchers are quaking with terror over the new information, since it has long been evident that something was wrong with our previous theories. Many scientists are happy with the discoveries. Researchers should have been alarmed by the disparities in the universe's expansion rate measurement alone years ago, but they stuck to antiquated beliefs rather than accurately understanding the warnings. It is believed that the cosmic microwave background radiation, or CMB for short, is the earliest light in the cosmos, around 380,000 years after the Big Bang, when the cosmos had cooled down sufficiently for protons and electrons to combine to form stable hydrogen atoms. The CMB was produced when American physicists Arno Penzias and Robert Wilson were developing a new type of antenna technology. They noticed a constant noise coming from every direction in the sky. They named this transition reionization, and this change made the universe permeable and able to emit light. This discovery was long considered one of the strongest pieces of evidence for the Big Bang theory in the annals of astrophysics. Penzias and Wilson shared a Nobel Prize and discovered that the CMB most likely provides a glimpse into the early universe. Scientists utilize the CMB as a trustworthy imprint of the fundamental metrics of the material cosmos to estimate the expansion pace of the universe, among other things. Tiny temperature fluctuations are crucial sources of information about the circumstances in the cosmos shortly after the Big Bang. The Hubble law, also known as the Hubble constant, was first calculated by astronomer Edwin Hubble in the late 19th and early 20th centuries. At the time, Hubble lacked the sophisticated measuring tools that were used decades later when the Hubble constant was discovered. Researchers recalculated the rate using the Type 1a supernova as standard candles, and the new value was significantly lower than the figure Hubble had initially calculated. By comparing the observed brightness of standard candles with their real luminance, the distance is determined. An expansion rate of roughly 67 kilometers per second per megaparsec was obtained from the CMB data, but an expansion rate of roughly 74 kilometers per second per megaparsec was obtained from the supernova measurements. What does S8 actually tell us? Did you know that since the 1990s, scientists have been aware of this discrepancy in estimating the universe's expansion rate more accurately? They have suspected that there might be a problem with the CMB's evaluation, the concepts of universe expansion, or the methods of measuring. The Hubble tension, also known as the S8 tension, is the scientific term for the difference between the different measured values of the universe's expansion rate. The ramifications of this tension go beyond simple differences in measurement. Rather, the disparate findings reveal fundamental flaws in our current understanding of the universe, which have long perplexed scientists. This has been the case since the James Webb Space Telescope was put into operation. Scientists' understanding of the universe's expansion rate may now be clarified by some surprises that the telescope has revealed. Galaxies that are so old and developed that their formation must theoretically predate the Big Bang are completely upending the conventional wisdom in astrophysics. Disparities or differences in measurement are no longer discussed. Scholars are discussing the largest challenge facing modern astronomy. Not only could the universe's expansion pace be incorrect, but the Big Bang theory itself is being called into question. The photos on the internet show evidence of a world that differs greatly from what we have long believed. The S8 tension served as a warning, and all researchers who continue to cling to the antiquated theories now face the question: do we really know nothing about the universe? A lot of scientists are standing on the rubble of their life's work, staring into space with fear and confusion about what they are seeing. In light of the scientific crisis, we must ask, what do we really know about how the universe functions? In order to move from the general to the specific, theoretical scientists employ a complicated network of mathematical models, empirical data, and deductive reasoning. Their knowledge is derived from a combination of observed phenomena, experimental findings, and numerous theoretical studies. Just the word theory indicates to us that these are concepts and ideas rather than absolute truths. The only useful information we possess is the images that radio telescopes provide us with, the sound waves and radiation that we can record with radio telescopes, and the most recent data that neutrino measuring systems or gravitational wave detectors bring us. With the James Webb Space Telescope, we now possess a tool that allows us to analyze the oldest light in a way that has never been possible before. We can determine which elements were predominant in galaxies more than 13 billion years ago, how much mass was contained, and how many stars this indicates. The telescope can reconstruct the shape and direction of movement of a galaxy. However, Webb can also have flaws in some images, like any task. We must acknowledge that over a considerable amount of time, our science has evolved in a way that has ignored alternate explanations and accepted far too many scenarios as true. It has long been established by studies that the most recent results from the James Webb Telescope are significant. New discoveries are too wild for many researchers to come up with new explanations at this time, and the new findings are upending the fundamentals of our physics, which worries many researchers. Clues to replace theories with new truths, as has happened dozens of times in science, may arise. Isaac Newton, who conducted research in the 17th century, is largely responsible for the teachings of physics that are taught today. His laws of motion and gravity served as the cornerstone for centuries of physical understanding of the real world, including the universe. Newton's laws of motion describe how objects move in everyday situations and work pretty well in space and on Earth, but they needed to be expanded, and Albert Einstein did this primarily at the start of the 20th century. His special theory of relativity, which was published in 1905, completely changed how we think about space and time. The general theory of relativity was developed in 1915 and expanded upon Einstein's findings that space and time are relative to one another and depend on the motion of the observer. These findings included mathematical demonstrations of gravitational phenomena based on the curvature of spacetime by massive objects like stars and galaxies. Although there were many areas in which Einstein's rules and theories made sense, he also had limitations. Throughout his life, the researcher was aware that his theories would never be adequate to fully capture the universe. He had a fantasy of discovering the world formula, but he was unsuccessful. Coincidentally, no other researcher has been successful up to this point. If we could figure out where the error is, it would be interesting to know. The well-known American astronomer Michio Kaku stated in an interview that the winner of the Nobel Prize will undoubtedly be the one who answers this puzzle. Let's examine some information that scientists might have missed, where they might have misconstrued phenomena, or if our telescopes are at fault. Dark matter and dark energy are the main hypotheses for the true origins of the cosmological crisis. Our current universe models consist of theories that dark matter and dark energy together account for approximately 95% of the universe. They have never been directly observed, and as a result, their true existence has never been established either. They don't exist at all, in which case we would need to find alternative explanations for the universe's expansion and galaxy dynamics, or they may have properties that we are currently unaware of. One theory that is currently being discussed is that the physical characteristics of the two dark components have changed over time, which may even indicate that we are dealing with extraterrestrial intelligence. The next test will be gravity, which is supposed to lead to attraction through mass or curvature in spacetime. Although Einstein is largely responsible for the concepts of spacetime curvature, and they have been repeatedly demonstrated to be accurate, we are presently unable to completely rule out the possibility that gravity has entirely different properties than previously believed, or that a different effect is responsible for the gravitational pull that forms on and between objects. Over decades, numerous values known as cosmic constants in cosmology and astrophysics have been established. These are values that are generally dependable because they don't fluctuate. Calculations have revealed that even small variations in these purported constants can add new momentum to the universe and allow us to explain a variety of phenomena without the existence of dark energy. It's also possible that our interpretations of the redshift of light are incorrect, that for decades we have measured the wrong distances within the universe, and have also calculated the age of galaxies incorrectly, or that our assumptions about the initial conditions of the universe were incorrect. It's also possible that the universe cannot be traced back to a single starting point, which would mean that the Big Bang theory is incorrect. Despite our advancements in technology, we cannot rule out small errors in the Webb telescope or other observational instruments. In the face of the crisis, engineers and scientists acknowledge that mistakes might always occur in the processing or interpretation of instrumentation data. Sign up now to ensure you never miss a thrilling new video.